Welcome to the Audio Architect third-party controller overview. In this video, we won't be writing any code, but we will be looking at the third-party controller device to help us generate control strings for users who wish to use a proprietary control system, such as AMX for controlling and monitoring SoundWeb London device parameters. It should also be mentioned that throughout this video, the terms command, message, and string will be used interchangeably. BSS SoundWeb London devices possess the capability of accepting commands via serial or TCP/IP. The message structure remains the same regardless of which is used. If utilizing a serial connection, a null modem, otherwise known as a crossover cable, is required. Correctly formatted messages transmitted to a SoundWeb London device are acknowledged with a message of hex 06 confirming receipt and checksum. If the checksum is invalid, then the negative acknowledgement is returned with the hex value of 15. A SoundWeb London serial port connection may be changed with the device's properties. It can also be configured to wait for acknowledgement for each message it transmits to a third-party device. Setting this to yes means that if an acknowledgement or negative acknowledgement is not received within 1 second, then the SoundWeb device will retransmit the message. If instead using TCP/IP for control, acknowledgements are not used considering TCP provides reliable data transmission. SoundWeb London devices listen for messages on port 1023. Control messages can be transmitted to a single SoundWeb device or multiples. However, it is only necessary to establish a connection to a single device on the network. Messages intended for other SoundWeb London devices will be forwarded as necessary. Before moving forward with this demonstration, it should be mentioned that the following actions may not be required considering many third-party control manufacturers supply already written modules for controlling SoundWeb London devices. Check at bssaudio.com or with the control manufacturer for more details. Alright, let's look at how we can discover strings for controlling parameters in a SoundWeb London device. We can add a third-party controller to our design from the controller options. Next, let's double-click on it and we'll find several options in the ribbon. If you've already watched the parameter preset recall video, then you will already have seen the parameter presets mode in action. In this video, we'll just focus on using the device parameters mode. To the right, we see options for duplicating or deleting strings in addition to undo and redo options. We'll look at the format options in a few moments. In order to control a parameter in a SoundWeb London device, it is necessary that we use the correct bytes of info. In order to generate a control string in the third-party controller, we can either use the Venue Explorer to drag and drop parameters, or we can navigate to our device and open the control panel for the parameter we're interested in. Let's open the gain-n input and move back to the third-party controller. Let's take a look at the type of strings we can generate for a gain parameter. Let's control-drag the Zone 1 fader to the workspace. Starting at the left of the row, we find the device the parameter originates in, providing us with a node address. The second column displays processing object category, either audio or logic. The third column provides us with the object name and ID. The fourth column, in this case, displays the channel. And finally, the fifth column displays the parameter itself along with its ID. Next to this, we find a drop-down menu allowing us to specify a type of string. By default, we are provided with the set command allowing us to specify an absolute decibel value. By clicking on the parameter ID field, we can view this string at the bottom of our window. Every SoundWeb London message will have a start byte of hex 02 and an end byte of hex 03. The last byte prior to the end byte is a checksum, which is an exclusive OR of all bytes in the body before any byte substitution is applied. More info on byte substitution can be found in the additional resources such as London DI Kit or the SoundWeb London third-party application guide. The body consists of the message type, node address, also known as the device ID, the object address, parameter ID, and data corresponding to the parameter value. The string can be copied to your computer's clipboard to be pasted into your working code. More set strings for the gain object can be generated by clicking on the duplicate option in the ribbon, and then a new value can be entered such as -3 dB. If we copy and paste each string into a text file, we can easily see how the data bytes and checksum have changed. Let's take a look at the format options. We can format strings for AMX or Crestron, which in turn sets the prefix, separator, and base accordingly. Use the custom option to change these values according to manufacturer guidelines. The source address acts like a HiQNet device ID for the third-party controller and always defaults to 51. In addition to this, an IP address can be specified for the third-party controller. Changing either value does not alter the discovered strings. If we set the format to AMX and then copy the last string and paste it into a text file, then we can see that while the bytes remained the same, only the prefix and separator changed. Next, let's duplicate the string to have a look at the other message types available. A set percentage allows the control to be set according to a percentage value. Set and set percentage commands can be useful for stepping through values of the control with less granularity. A subscribe command will return a set or set string command, providing the third-party controller with the necessary info for updating the user interface with the current values. As the parameter continues to change, the third-party controller will continue to receive updates for the new values until an unsubscribe command is received. Similar to the subscribe and unsubscribe message types are the subscribe and unsubscribe percentage. A Soundweb London device receiving a subscribe percentage command will return just that, a percentage value. Subscribe and unsubscribe percentage commands feature a time interval. For all controls with the exception of meters, this is fixed at 0 milliseconds. When subscribing to a meter, this value can be changed. It is recommended to start out at 50 milliseconds for a meter, but proceed with caution. Subscribing to many meters can begin to consume bandwidth and flood the control master. Within Soundweb London devices, we also find the message type of bump %. This type of command is not available to Crown networked amplifiers. The bump percentage allows us to specify a percentage value either positive or negative. Generally, if we bump up a control, say by 3%, then we will have the option to bump it down by 3%. If subscribed to a parameter that has been changed using the bump percentage message type, then the device will not return a set or set percentage value after every bump. A subscribe or subscribe percentage command must be issued to the Soundweb London device to receive the new value. Once all the desired strings have been generated, they may be exported to a comma-separated value file using the export feature located within the ribbon. A common example for controlling a single gain object can oftentimes just require a total of 3 strings, one to bump up by 3% and another to bump down by 3% in addition to subscribing to the parameter. Here we see an example of some AMX netlinks code written using the strings within a couple functions for controlling bump up and bump down. This concludes our overview for generating third-party control strings. Be sure to look over the additional resources, and thanks for watching.